Hello everyone, this is Shubham Chaudhary and I welcome you again in the 21st video of our YouTube channel. Today, today is 21st January and we are discussing this LeetCode medium problem number 198, house robber. So here they have given, let's suppose you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Here, they have given an integer array nums representing the amount of money of each house, and we need to return the maximum amount of money we can rob tonight without alerting the police. So, from this, you can assume that the solution will be the addition of the odd indices and addition of the even indices and return the maximum of that addition, which we will get for here. But these are the two sample cases. You will face error in the next hidden test cases. So the problem is not only for two adjacent houses. We need to calculate such pairs which will include which will not be there only for adjacent houses. So we don't want to see here that two adjacent houses should be there. Every pair which we will calculate to the sum should not be the adjacent to each other. Only this condition should satisfy. So there will be a test case which will false this approach of adding the even indexes and the odd indexes. Let's discuss the approach. First of all, this will be the test case for nums of array. This let's let's ex- let's check the explanation of example 1 and 2. First, here the nums array is this. So first house will have one amount, second house will have two amount, and third house will have three amount, and fourth house will have one amount. Here we will rob house 1 and rob house 3 so that we will gain the maximum amount as 4. And in the next example we will rob house 2, then 9, then 11. So addition will be 12, and second one will be we will rob 7 and 3. So addition will be 10. So 12 is greater than 10. So we will rob 2, 9 and 1. Now this test case will fail the even odd indices approach. Here 40 to 410. So we will add 40, then 4. So we will get 44. And the second way is 2 and 10. We will rob 2 and 10. So 12. And maximum of 44 and 12 we will get 44. But that's not the right answer. The right answer will be 50, as we can drop 40 and 10. 40 and 10. So the amount will be 50. As in the questions, they said two adjacent houses, but they but the houses we are taken should not be the adjacent houses. This condition we need to take in our mind, that every house that we are getting as the amount, we should not be adjacent. So we will take 40 and 10. This will be fine, and we will return 50. So for this, the question is based on dynamic programming. So as per the dynamic programming approach, we will create first a DP array of size n plus 1, where n is the size of the array. Now For this, the size is 4, so we will create dp of 4. So sorry, dp of 5, n plus 1. After that, we will initialize dp of 0 as 0 and dp of 1 as nums of 0. Here, we will store dp of 0 as 0, as we are not storing the amount here in the first 0th index. We will store amount from 1 to n indexes for corresponding nums of array. So we will iterate through the loop after that. Here, before that, we will update dp of 1 as nums of 0. Here, we will take dp of 1 equals to 0th index of nums. So our new dp array is starting from 1 for nums 0 starting from 0. So we need to take care of that in the formula also. And after that, we will iterate through the loop here. And for dp of I, we will take maximum of dp of I minus 2 plus dp of I minus 1, sorry, nums of I minus 1, or dp of I minus 1. Here we are taking maximum of dp of I minus 2. First, second first element of the dp plus current elements addition, current element from nums array, or the previous element of dpr. We will take maximum of that and we will update that value in the dpr. And after that, we will return dp of n. So for this example, let's discuss the approach. For 1 2 3 1, the 0th index of dp array will be 0, as we are assigning it 0, and the dp of 1 will be nums of 0. Then for dp of 2, we will iterate this loop. So dp of 2 will be equal to dp of I minus 2, that is 0, plus nums of I minus 1, that is 2. So 0 plus 2 equals to 2, or dp of I minus 1, 1. So maximum of 2 and 1 we will get is 2. So for index dp of 3, so for dp of 3 we will get maximum of this 3 plus 1, 4, or this 2. So 4 and 2, we will return 4. Then for this index, we will take maximum of 2 and 1. 2 plus 1 is 3 and 4. So 3 and 4, we will return 4 here. And after that, we will return 4 because dp of n we need to return. So in the second example, the approach is similar. We will assign dp of 0 as 0 and dp of 1 as nums of 0. Then dp of 2 will be equal to 0 plus 2 or 40. So 2 and 40, here 40 is maximum, so we are updating 40. After that, for this index, we will add 40 plus 4, 44, or 40. So 44 or 4, 44 or 40. The maximum value is 44, so we are updating 44 here. And at last index, we will take 40 plus 10, so 50 or 44. So we will update 50 here. And after that, we will return 50. So this is the approach here. If you didn't get it, then rewatch the video again. Let's code for this solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So we will, first of all, we will create an variable for storing the size. We will check if n equals to 1. If the array size is 1, then we will return first element of nums array. After that, we will assign dp of 0 as 0 and dp of 1 as nums of 0, the first element. After that, we will iterate through the for loop, which will start from I equals to 2 and I less than equal to n, I plus plus. Here, we will use that formula for dp of I equal to maximum of dp of I minus 2 plus nums of I minus 1, current element in the nums array, or dp of I minus 1, the previous element of dp array. So here the formula is similar. We are calculating maximum of dp of I minus 2 plus current element or the previous element. So here also dp of I minus 2 plus current element or the previous element, maximum of both of them, then we will update that in the dp of I, and after that we will return dp of n, that is the last element of the dp array. Now let's check for the solution. dp array is not created here. Create a dp array of size n plus 1. Here we need to create the dp array with array size plus 1. As we are storing dp of 0 equals to 0, it is a void. Let's check again. Yeah, the test cases ran successfully. Check for the hidden test cases. Yep, the code ran successfully. Here, the time complexity will be, as we are iterating through this for loop for I equals to 2 say n. So the time complexity will be big O of n, and the space complexity will be big O of n, as we are creating this dp array of size n plus 1. So overall space complexity will be big O of n. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content. Stay tuned for upcoming LeetCode problem of the day videos and exciting month-stack web development projects. Happy coding, and let's make this year a fantastic one together. Thank you.